What I have here is some equipment which is going to help us to study motion. In particular, we're going to have a look at three types of motion. One is uniform motion, which means the trolley here will be moving along at roughly the same speed. The second is accelerating motion, in which this trolley is going to be speeding up. The third is deceleration, and we're going to have a look at this, slowing down. So there are three aspects of those three motions that we're looking at. One is displacement or position. The second is velocity, sometimes called speed. And the third is the acceleration itself. So what I've got over here is a motion sensor, and what that sensor does is it sends out pulses of sound, ultrasound, so that we can't hear it, and at a frequency, let's say, of 50 times a second. That hits the back of the trolley, bounces back, and then the data goes to the computer. Well, let's have a closer look at the data logger and the motion sensor itself. Well, here's a close-up view of the equipment. First of all, it's the motion sensor, and on the top of that motion sensor you can see a little sign here. That has to be set across there to the trolley. That leads to the data logger itself, and you can see how that's plugged in there. And at the back we have a lead there which goes to the computer, and that lead there is a power lead. At the front here, it's plugged, this plug is pushed into here, and you have to make sure that this is blue in order to ensure that the thing is actually on. Now, when this motion sensor is in place, it just clips here onto the end of the track. What you have to do is make sure that this is pointing right down the track. Sometimes students have it like that, and they're measuring the velocity of the ceiling and wondering why it doesn't move. So you just have to be that little bit careful. Now let's look at the software. So first of all, I need to click on this icon here, Pasco, 2 clicks. And once that comes up there in the top left, you can see a little blue patch. And once this comes up, that tells me, particularly that green line there, tells me that the equipment is set up correctly. If that is red or doesn't appear, you have a problem. Now once I've got done that, I move up again here and just close that window. Now I move my pointer right across to the top right and click twice. And that gives me 1 graph. I want 3 graphs, so I'm going to go. And then this graph I want to measure the position, this graph the velocity, and this graph the acceleration. I'm going to adjust the frequency down here to 50 Hertz, so that it will give out 50 signals, 50 sound pulses every second to pick up the motion. So once I've got that set up, I click on the record button here. I put the trolley in a position here 15 centimetres from the motion sensor and give it a push. So these are the results that I've got, and they do look a little bit messy, but what I'm going to do is try and make a little bit more sense out of them. So it looks as if the motion started there about 2.5. So I'm just going to adjust that to there and bring this down here to 0 and stretch this across here to about 4. So what I've done there is I've put my pointer over the numbers on the x-axis, and then I'm going to stretch up the scale here that's on the y-axis. Now there is a little bit of a dip there, so I might get the uniform motion as going from about, say, 2.5 or a bit more seconds to up here where it is straight. So over here I need to do a fair bit of adjusting to the axis again. So I'm going to pull this down so it's sitting on 0 and then adjust the scale so that it matches the time scale over on the displacement. So I'll have to keep moving this up. This is not unusual to get these big figures here for the velocity, and they don't make sense. Okay, so you can see now that if I stretch this out, I get a period here of from somewhere around about maybe it's 2.75 across here to 3 point something. Okay, I've got 3.8 sitting there, so I might adjust this to get the 3.8, see if I can get the 3.8 sitting there as well. And now with the acceleration, again, I've got to do a lot of adjustment here for this y-axis. Okay, so now we're getting something reasonable, an acceleration there of 2, 1. Well, again, what I need to do is stretch this axis out to match the other two axes. So that's 2.8 and stretching it across there to 3.8. Right, so we've got that matching there. Now I'm going to reduce the scale here. And it looks there as if the acceleration is kind of all over the place. Basically it is sitting there on 0. But what we have to do is keep in mind the way in which the computer works out the acceleration. What it does is it works out the gradient between each of these two dots up here in the acceleration graph. So this measure of the acceleration often enough is not a good one to really measure the acceleration. But as you can see there, most of those dots do seem to be round about 0, suggesting that the acceleration is 0. If we can come up here and have a look at the slope of our velocity graph, what you can see actually is that there is a slight decrease. There is some deceleration in this particular case. So what we're going to do now is save this. I'm going to go up here to File, and what I need to do is to scroll down to Print Page Setup. And once I do that, I can then select the size, which is A4, which is okay, but I do need to select Landscape. So I'll go OK, and then I can go to File, and I can go to Print, and just make sure that it's going to print from the printer which is in this room, which is 335, so I need to click on that one, and then I can click Print. The next aspect of this motion that we're going to have a look at is accelerated motion. So in order to do that, what I'm going to do is I'm going to lift this track up so that it is sitting at an angle. I'm just going to put a box underneath that, and then we can make a start. Now I've clicked the record button, so I'm placing this now 15 centimetres away from the motion sensor, and I'll let it go. And you can see the graphs that I've got there. So again, what I've got to do is some adjusting so that we can see the things that we want to see. So we're looking for acceleration, and as I look at this graph, that of course there tells me that it's not moving. Here it's not moving either. So what I'm going to do is move this across here and stretch this out again. And here you can see we're getting a bit of an exponential curve. So I'm going to adjust that about there. I'll look at the velocity graph, adjust this down here to 0, change the vertical axis, move this across to around about 20.8, have it 20.8 sitting there, stretch this across. So you can see you have to play with this a little bit to get the readings that you want. So I have that sitting there on 0 and stretch this across. So what I've got there is 22.4, 22.4, 28, 20.8. Over here with the acceleration, I'll bring this down. So that's sitting on 0, then extend the y-axis across here to the 20.8 and across again here to 22. Okay, so we've got 22.4 there, and if I adjust this across further to 20.8, there on that mark, and across here to 22.4, 22.4 there, 22.4 here, and now I can do some comparisons. First of all, I'll increase the scale here so I can get a better picture of the acceleration. Now you can see from the results of this graph that we've got two ways of getting the acceleration. First of all, we can work out the slope of this graph. The second way is to read the acceleration from here. And what we can do to work out which is the more accurate way of doing it is make some sort of judgment about the uncertainties. Which of these two will have the greatest level of uncertainty? Getting the gradient from here, from the velocity time graph, and or reading the acceleration from this particular graph. So what I'm going to do now again is to print this particular graph. We're now in a position where we can study the deceleration. What I've got down here at the far end is the trolley, and I'll give that a push so it'll go up the track and I'll record that movement upwards. So that looks like a good push. Now I'm going to adjust the graphs that I've got. Now you might recognise that what I'm doing here is taking note of the way in which it moved away from the motion sensor. So it was round about 2 metres away, and then it got closer and closer to about that time. So that's the time it was slowing down. So again, what I'll do is I'll adjust the velocity time graphs to go from 12 point something. I'll adjust the vertical axis here. I might take that as 12.5 up here to 15.5. So those are my three graphs, and as you can see here, the trolley goes from about 1.4 metres away to perhaps 20 centimetres away and back away. And so we've got measurements there for its velocity. It's obviously that is changing, it's getting less and less until it gets to there, 0, and then it starts increasing, going down the slope there. It's an interesting question as to whether or not the acceleration here, the gradient here, is the same as the gradient there. That's an interesting question. Right, so there are the three graphs of the three types of motion, and you are now in a position to do some processing of those results.